All right. So today in Mr. Jeffrey's Algebra 2 with Stats class, we're going to be going over modeling polynomial functions. Okay. Now, this does not mean that we have a polynomial function that kind of like comes down the catwalk and does a little turn on the catwalk. Yeah, on the catwalk. And if you know that song, 2 extra points. Just want to thank all my followers, my 50 plus. And if you're not following, go ahead and hit subscribe, like it. I am looking a little orange today. It has nothing to do with right here is what's on the TV. I did eat a couple of tangerines last night, so that could be it. Or it could be eating those seaweedies that was in the Magic School Bus thing that turned the kid orange because all it was seaweed wrapped around carrots. He ate so many carrots, he turned orange. So, yeah, yay, carrots. All right. So, this is what we need to do. All right. Step 1, use the x-intercepts to write a function in factored form. All right. This is kind of like how we did it. Now, our x-intercepts are like this. But remember, when we write them in the equation, we had to do the opposite sign. Okay, so instead of -4, we're going to have x plus 4 because this is what we would do before we solved it. Okay, instead of +1, this would be -1. Instead of +3, -3. All right, that's awesome. Now we have just this one little thing to find a right here. All right, and this is what we do on this one. This is our y-intercept right here, this 0, -6. All right, we're going to plug in -6 for f of x because this is understood to be y. All right, so -6 goes here. And we're going to plug in 0 for x because if it's on the y-axis, x is 0. Okay, bloop, bloop, bloop. And then we solve. Okay, so we have -6 equals, let's see, what's 4 times -1 times 3? Yeah, -3. Yeah, it is 12. So we have 12a. And what would we do to solve that? Yep, divide by 12. Okay. So we actually end up getting a equals -1/2. And now we just write our function. And apparently I didn't give us enough room, but potato, potato. So f of x equals -1/2 x plus 4, x minus 1, and x minus 3. Okay. Now, yeah, go. I was reading these notes from the textbook that y'all don't get, and because who would want a textbook to carry around that you never open? And plus, if you were to take it home, you may lose it, and then you're responsible for that book. So, Yes, what was your question? Yep. Yeah. It seems really crazy at first. Yeah. Yeah, because, that's our y-intercept because we only have a y function and x is 0. It seems kind of crazy, but once we did it a couple times, y'all were like, oh, this is pretty easy. Okay. Because I did it a couple times. I was like, okay, I feel much more better. Okay. And I'm trying to hide the watermark here because apparently we're still in limited mode. All right. Whoops. Straight line. I'm going to move my face. Okay. So, first thing we need to do is find our x-intercepts. All right. And we're going to plug it in to this right here. All right. What's our first x-intercept as we read from left to right? Yeah, -1. But when we write it, yes, I did hear it. It is an x plus 1. It's the opposite. Okay. Our next one, as we read from left to right, it says 1, 0, but when we write it, it has to be the opposite. Okay. And this same thing with 2. All right. So those are our x-intercepts. All right. Now, to find our, do I need to wait a little bit to let y'all catch up before I move on? Okay, I just see people writing and I think I need to stop and let people catch up. Okay, no, that's, if you're going ahead of me, that's okay. Now, what is our y-intercept? Yeah, so we're going to put 2 right here because that's, our f of x is understood to be y. Those are transversal, okay? And we don't know a, that's what we're solving. All right, now, what are we going to put in all these spots? Yeah, where x is, we're going to put a 0. And some people are used to seeing that on math anyways. All right. So we have 1 times -1 times -2. So this becomes a 2a. And we solve by dividing. So what does a equal? 1. So you could rewrite it if you get a 1 on the test or something. For me, I'm not going to like eat your face if you write it like this. But you don't have to write the 1. A lot of standardized tests and some other teachers will, say, "Oh, you're supposed to know it's understood." Well, if you understood it was understood, you wouldn't have to write it. So maybe you need to understand. All right, like this. This is the answer. Because we're just taking what we had. Let's see. Let me get the little bouncy thing again. All right. Follow the smiley face. All right. So we plugged in bloop, 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 our x-intercepts. Okay. And that's how we got these numbers here. Then we plug in our y-intercept. Well, the 2 goes here because f of x and y are the same thing. And everywhere we see x, we're plugging in a 0. Okay. Because we're all trying to find this a right here, which we found was 1. So once we find a, we literally just take everything that I have written up here in black and stick it back down here with what we found for a. That's it. I think using the smiley face or something has actually helped a lot of students because you can't see the little cursor thing. So I think it's fun. It's like the sing along songs, where it would bounce along. Because I know y'all did the sing along. What is it? High School Musical, the sing along edition, huh? VeggieTales sing along edition. Yeah. If you like to talk to tomatoes. All right. Now let's look here. I'm going to start writing in purple. Yay, purple. All right. What is my first x-intercept right here? 3. So it says -3, so we have to do the opposite, so it's plus. Okay. What is the next one? Yeah. And our last one? Yeah, we have to write -2. All right. Now, this one was kind of tricky right here. There's 2 y-intercepts. All right. Well, we could do a couple of things. Okay. We could guess what this is and use that as my x-intercept, or I'm sorry, y-intercept, or we could plug this in for x and y and solve from there. Either way, we should be okay. So let's do with what we have been doing, because Mr. Jeffries is going to make sure that you have y-intercepts on your test. Is that what you were worried about? Okay, so this intercept right here looks to be like -1, -2, -3. So this is 0, -3. Oh, no. Oh, it's by twos. All right, so this is 2, 4. Oh, yeah, that makes more better sense. Sorry. Yes, it's -6. All right, so -6 goes here. I'll leave my A alone. All right, now. All right, so we plug this in. Let's see, 3 times 1 is 3, times -2 is -6. Yep, so we actually get 1 again. So I need a different color. Let's do brown. So we would have f of x equals, you could write the 1, you don't have to. Okay, of all the things, look, there is nobody here, hardly. We have like maybe half the class. We have 31 in class. We have like most of them are gone to a volleyball game. That's good, go Jets. But I have 2 students that are continuously talking about random crap. And especially since one of them brings in a 16-course meal to eat throughout the day. And apparently, no, 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 no. I don't want more students to just start having random conversations. I like it when Oh, I know. I like it when you're your normal quiet self though. Yeah. Yeah. Like to me, like y'all, yeah, whenever I'm recording, yeah. Yeah. I know. It's very appreciated. Yeah. Yeah, it would be very odd if when I was recording, you would be talking about how you're playing Minecraft in class, like when I'm not recording. You know. Okay. No, you don't. Shh. All right. So, shh, 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 shh. Now, y'all look at number 5, and then write this down. Okay, I'm gonna skip this because I put this on here without really going through it. Okay, this doesn't have a definite y-intercept. We could kind of guess right here and say that this is 3, but I don't want to guess. I want to know why we're giving this extra point right here. Okay. Um, so we're going to come back and look at that. We could go ahead and do this part though. Um, this would be x plus 5, x minus 1, and x minus 4. So, you know, to find A, I'm going to come back and look at this. Um, if it's as simple as plugging in 3 and 0, that would be fine, but I don't really want to do that because if I plug in 0, I'm going to end up with like 3/20. And that doesn't sound like a whole lot of fun. Um, would rather get a root canal with somebody that, doesn't handle their faculties very well. So, all right. Now, Number 6. We can do number 6 because it has a. Oh, I'm just going to write on number 6 for no reason. It has a definite y-intercept this time. All right. So we start with this. Start with the a. All right. This is -6, so I have to write x plus 6. This is -3, so I'll do the opposite, x plus 3. And this would be, I'm going to move this. There we go. Move this down. This would be x minus 3. All right. I'm definitely given a y-intercept right now. It's labeled. I want to use it. Yep. And 0 goes here and here and here. So I have -9 equals, let's see, 6 times 3 is 18 times 6 times 3 is 18 times the -3 is -54. A. And then when we divide by -54, if I could write, nope, not 6. 54 divided by 9 is 6. Yes, 1/6. So, and now we just do it in. 1/6. Whoa, that is a weird looking 6. That looked like it wanted to start like a number and then turn into a letter and then turn into something that's unlegible. All right. All right. So, now, not so bad. I will double check to make sure that we have, well, on the test, we'll make sure that there are y intercepts or show you how to do the ones that's not listed. All right, to the back. All right, believe it or not, the way this is written is a lot less confusing the way it's written in the textbook that y'all don't have. It says if the x values are equally spaced, then when you do the differences of the y values and it gives you the same number, that's the degree of the polynomial. Okay. Now, even I typed that out and I was like, that still sounds confusing. Well, let's just do this. First of all, let's look at our x's to make sure that they're evenly spaced. This goes 1, 2, 3, 4, 5, 6, 7. All right. So they're equally spaced. Awesome. All right. Yeah. From 1 to 4, I get 3. What about right here? How do I get from 4 to 10? Okay. 10 to 20. Okay. 20 to 35. Okay. 35 to 56. 21. And 84 to 56. Yeah, I know. That's, listen, I stopped right here. I was like, with my mental math, and I was like, I needed the calculator. Yeah, 28. All right. That's our first difference. None of them are the same. Okay. Yeah, but they have to all be the same number all the way across. Okay. So we know it's not a first degree. All right. Because that would be linear. And why would we be studying linears when we're doing polynomials? Yeah, we did this kind of, this is how we found with quadratics. All right. How do we get from 3 to 6? 6 to 10. 6 and 7. All right. We're getting closer. They're getting closer to the same. All right. Now, last time. How do we get from 3 to 4? 4 to 5. 5 to 6. 67, 1. All right. So finally, the third difference, because this is the first, this is the second, and this is the third. This tells us our degree. Now, we could go online to actually type in these x and y values, say it's the third degree. It will do a polynomial regression for us, and it will actually tell us what this equation is. I'm not asking you to do the technology part right now. I'm asking you to do this because, and this is the reason why, when I was practicing this, and people at home, you may want to do this too. When I was practicing this, before I could use technology, I had to find the degree first of anything I found online. So if you can't find the degree, you can't do the technology thing correctly. Resources. Yeah. All right. So, yeah, this is what we're doing. Mm-hmm. Yeehaw. All right. So let's see. These look like we're adding 3 each time, so they're evenly spaced. All right. To get to here, I add 17. Okay. Gets fun. Yeah, I subtract 19. Looks like I add 53. And then I add, let's see, come here, calculator. You're my best friend. Let me tell you about my best friend. 233. Listen, I thought it was no, 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 no. I thought it was kind of odd because I was sitting here and I was doing this yesterday, and I was like, okay, like that example we just did. Um, okay, thank you. And this was 233, and this one is 521. When I was doing this yesterday, I was like, oh, those numbers were fairly easy to do in the example. The example we just did was actually the example in the book. This is what would be for homework. Do you see how the numbers jump? It is a bit much. Okay, so this is our first difference, so we know it's not a first degree. Okay. So let's see. I want 17. From 17 to negative 19. So negative 36. All right. Let's see. 53 minus negative 19. All right. This is 72. This is 180. This is 288. And the way I found this, like I actually typed in 53 minus negative 19, or 19 minus 17. That's how I got it. All right. So this is our second. Nope. It's not close at all. All right. Yeah. All right. So 72 minus negative 36 gives us 108. All right. Yeah. Yep. All right. From here to here, this is actually 108. And believe it or not, this is actually 108. Yeah. So it's the same thing all the way through. So this is actually a third degree. All right. Now, I'm going to stop recording because my laptop is about to go kaput, and my students in class are actually about to finish doing this. So, again, thank you, all my subscribers. Don't forget, hit the like button, hit the bell, and subscribe. Good stuff, good things. Roll Tide.